Applications of quadratic equations.
Quadratic formulas can be used to figure out projectile motion, meaning how high and how far a moving object travels.
Peggy Prendergast is throwing lots of her belongings out the window of her apartment on the 8th floor. Peggy, that's taking spring cleaning a little bit too far, don't you think? The first thing she's tossing out, her old record player.
Gravity is a constant, so there's a special formula to figure out the velocity and height of an object thrown. That formula is negative 16x squared plus vx plus h. V is the variable for velocity, and h is the variable for the height where the throw originates. So, what are x and y?
What we want to figure out is how high our object is at a given time. So y will equal the height of the object, while x will equal the time the object is in the air.
Now that we've defined our terms, we need to start inputting some values for our variables. Peggy's apartment window is 80 feet from the ground. That's your starting height, so h equals 80.
Peggy was clocked at throwing 64 feet per second. That's your velocity, so v will equal 64 in our equation.
With values for v and h, our equation looks like this. You want to know the height of the record player after 3 seconds. If x, as we said, equals the time an object travels, in this case x equals 3. We can now put that into the equation.
First, we square the 3 in the first parentheses. That equals 9. Then we multiply that by negative 16 to get negative 144.
64 times 3 is 192. After adding it all up, y equals 128. How far will the record player travel after Peggy's thrown it?
But how can that be? How can the height, 128, be higher than Peggy's starting point, 80 feet above the ground? Well, it looks like Peggy tossed that record player high over her head.
Because of gravity, we know that what goes up must come down.
Here's a graph of our scenario. This represents Peggy standing at her apartment window and tossing out her stuff. To note that, we've marked the graph at y equals 80.
But we're going to make one change to our graph. Since we know that Peggy won't throw in reverse and that the record player won't go under the earth when it lands, we're going to remove any reference to negative numbers on our axes.
So how far will the record player go?
Because of gravity, no matter how high or how hard we throw anything, it will reach a point where it comes back to Earth. That will be our parabola's vertex.
We also know that it will hit the Earth if no other physical object is in the way. That will be our parabola's x-intercept. How do we find x-intercepts again? That's right, the quadratic formula. You remember that, right?
The quadratic formula states that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Let's work on this. First, we'll square 64 and do our multiplication inside our square root symbol.
Then we'll add those two numbers to get the square root of 9,216, which has a perfect square root of 96. Now we just have to solve twice for the positive and negative 96.
If we solve for positive 96, we get 32 in our numerator, which, divided by a negative 32 in the denominator, equals a negative 1.
This negative x-intercept is useless since we're ignoring all negative numbers on both axes. This is a valid x-intercept if we were drawing a full parabola, but we're not. So let's find the x-intercept that lies on the positive side of the x-axis.
Now we have to solve our quadratic formula for that negative 96 in the numerator. Doing that, we get x equals 5. So, our second x-intercept is 5, and y is 0. That sounds about right.
Now we can plot that x-intercept on our graph.
We might also like to know how high Peggy can throw her old record player. We already figured out the location of our vertex, which is the highest point the record player can reach at our velocity of 64 feet a second. But how can we calculate that? If our x-intercept is at 5, then the axis of symmetry has to run through the vertex and will be located halfway between our two x-intercepts. So let's figure out our axis of symmetry before we find the vertex. While we didn't plot both of them, we did figure out both x-intercepts. If those intercepts are lying at -1 and 5, they are 6 spaces apart. If the axis of symmetry is halfway between both points, then we divide 6 by 2. That means the axis is 3 spaces from both x-intercepts. So, the axis of symmetry is at x is 2 and y is 0.
Let's number the axis of symmetry on our graph. So what's the highest point on the axis of symmetry?
If 2 is a value for x for the axis, we have to substitute 2 for x in our original equation and solve for y. To solve for y, we'll first square our 2 in the first term. Then, we'll multiply the first term by 4 and the second term by 2. Then, we just add our numbers and y equals 144. So, our vertex lies at x is 2 and y is 144.
Woo-wee! That's some powerful arm she has.
Finally, we'll note where the vertex lies, and now we have our parabola. There you have it. Thanks to Peggy P for donating her old record player in the name of quadratic equations.
Happy algebra, y'all. Take care.